Hi everyone, Mark Kulababa, President and CEO of Adamera Minerals here to talk to you today about the Buckhorn 2.0 Gold Project in Washington State. This is a project that we staked in mid-2020, and in late 2021 we acquired a database from Kinross. This database has turned out to be far more valuable than we originally thought, and this video is going to show you why. This project is located in northern Washington State against the Canadian border. The claims are 70 kilometers by road and highway to the Kettle River Mill owned by Kinross. This is a good-sized project. It's 36 square kilometers. It's 100% owned by Adamera, and it surrounds the past-producing Buckhorn mine. Buckhorn mine was originally discovered by Crown in late 1980s. It was mined by Kinross between 2008 and 2017. It produced 1.3 million ounces of gold at an average grade of about 13 grams per ton. This was a very rich mine. Now, mines like this, in my mind, don't occur as single occurrences. I believe they occur in clusters or multiple occurrences. So our task now is to find more of these mines, and we've got a data set to do that. This data is 30 years in the making, and it is extensive and of much higher value than we originally thought. I was expecting something in the order of $3 to $5 million that would advance our exploration efforts by 1 or 2 years. Well, in reality, I think we're looking at a valuation of more like $15 million that would likely advance our exploration by 6 years. Let's jump into this. Let's look at the various data sets that we've got, and let me show you how we're layering this to develop our targets. Let's start off with soil geochemistry. The red dots represent soil samples that have been collected on the property. You can see an area that has not had any soil samples collected yet. We will deal with that this summer. But let's focus on the red dots. The larger dots specifically represent samples with higher gold values. Now here are a few selected values. 14.2 grams per ton gold, 18.9, 12.9, and 7 grams per ton gold. These are some very large soil values, some very attractive targets for us. It's important to note here that these high gold occurrences are not related to the known mine in the area. So there must be other undiscovered sources that are causing these gold anomalies in the soil. The surface rock samples, shown in blue here, also show some very exciting opportunities. Let's take a look at some of the values. 12.1 grams, 13.7, 37, 47.8, and 124 grams per ton gold. These are some extremely high values, and again, they're not next to the mine. They're on other parts of the property, which is very exciting for us. Part of this data package is a property-wide VTEM survey that was flown in 2008. Now that date is important. Much of the drilling on this property was done in the 1990s, well before this survey was flown. So now we've pulled off about 27 or 28 targets, and most of these targets have not yet been drilled. And we've got full coverage of an airborne magnetic survey over the entire property. Prior to closing the data transfer agreement with Kinross, we initiated a few surveys on our own to get some work done in 2021. One of the surveys we did is a ground mag survey, and here you're looking at an almost entire property coverage of ground magnetics. And this was shocking, the amount of detail we get in this survey and how useful it will be. I would not want to be targeting a gold project without this kind of detail. Here is a direct comparison of the ground magnetics with the airborne magnetics on the left-hand side. Immediately, you see the difference between the two. There's so much more detail in the ground magnetics. Now let's compare that area. Okay, on these maps, the white dots represent gold in soil, and you have a number of anomalous areas. In this area specifically, you can see using the airborne magnetics, you'd have trouble targeting that, whereas with the ground magnetics, you have far more detail, much better chance of targeting something important. Here's another good example of that. And here as well. Incidentally, this cluster is the Keystone project, and I will do a separate video on this. This is a very high priority target for us. Last year, we also did some VLF surveying. Let's take a closer look at some of that data and zoom in here. This map shows the coincidence between the gold values in soil and the conductors. The conductors are shown in pink, the gold values in soil are the circles. In this cluster, you've got a highest gold value of 1.4 grams per ton, 1 gram per ton, 12.9, and 7 grams per ton. So good coincidence between the conductors and the gold in soil. Of course, in mining, geology is important. Here's a geological map that we produced in 2020 and 2021. We also now have a number of postage stamp maps that we got from Kinross, and we're going to compile those into this map, and we'll have a property-wide geological coverage. And that's the first time that this will have been done on this property. Now, this is really important. This is the drill data that we received in the transfer agreement with Kinross. We originally thought we were getting drill data for about 28 drill holes. And in this case, we're looking at drill holes for 281 drill holes. That's more than 50,000 meters of drilling, and we put a value on that of about $12 million. Now think of the areas we don't have to drill looking at that data. Now let's do something interesting here. Let's plot the drill holes that have greater than 0.5 grams per ton to 1 gram. That's the light purple pink color. These are greater than half a gram. Now let's go to drill holes that have over 1 gram, but less than 5 grams. And now let's go above 5 grams to 10 grams. What are those values like? We're seeing some 7.2 grams per ton, 8.2 grams per ton, 6.9 grams per ton. These are drill intersections. And let's take it a step further. Greater than 10 grams. Here we've got 10.1, 17.2 grams per ton gold, and 45.2 grams per ton gold. You better believe that we have got a lot of opportunities in this data. This is going to be a big driver for us going forward. Now this is an interesting data set. It's just a little bit of fun. It's LiDAR. We can pick a lot of the old road access out, which is really helpful. We've been able to pinpoint old mine workings and go in and sample those to see what the values are. And then now we're taking it a step further, and we're looking at important structures that could be mineralizing. Let's take a look at this. The crew that did the ground magnetic surveying, when they came across old workings, they took a note of it and recorded a GPS coordinate. And so we got probably 130 different workings recorded that we could go out and sample and look at the geochemistry from that. We then took that data and modeled it within the LiDAR, and you can see in this map over to the right, these little dots in here, these are old workings. So it gave us more information, more places to go to see what's happening on the surface. Here's a good example. Here's some soil geochemistry. You got gold in soil along a structure, and we see intersecting structures, and these just give us a little bit of direction when we're building our targets. With 30 years of data collected, we put a value on that of about $15 million, and I really do believe this is going to advance our efforts by at least 6 years. We're not having to spend time looking or building targets or building data sets that we can use for targeting. That is done. Our focus now is on permitting and drilling and making the discovery of the next mine in this area. As you can see, we've developed a lot of targets on this property, and we will continue to do so. Future videos will start to showcase some of the details in these targets. Until then, I thank you for taking the time to listen. We're very excited by this project, Buckhorn 2.0. We're also very excited by the targets that are developing here. Thank you very much. Talk to you soon.